Before you watch the video, subscribe it, click on the bell icon for more notifications. Hi everybody, welcome to AGAA-MATH. This is Rakesh. Today we are going to learn about the solving the quadratic equation using completing square method. Even before we have learned the solving quadratic equation using the factorization method. Then why do we need completing square method? Here the example now. If the equation is given x square minus 4x plus 2 equals to 0. To find the roots of this quadratic equation using the factorization method, first of all we take like 1 into 2, the coefficient of x square, that is 1 into 2 is 2. And when we write the factors like this, where the sum or difference should be like the middle term, where we cannot split the middle term now, it's not possible, right? So to solve such quadratic equations where we cannot split the middle term, in such cases we use the completing square method, right? So let us see how do we solve the given quadratic equation using the completing square method. So first of all, I would like to take the general form of a quadratic equation and show you the derivation of that process, right? So the general form of a quadratic equation, we all know that ax square plus bx plus c equals to 0, right? So first of all, whenever I would like to solve the quadratic equation using completing square method, see that the coefficient of x square should be 1. But here the coefficient of x square is a. So that is the reason divide each term with a, right? So what I do is ax square by a plus bx by a plus c by a equals to 0 by a. So what do we get then here? As these both get eliminated, so we get x square plus b by a of x plus c by a equals to 0, right? Now just very simple, what you do is transfer this c by a towards a RHS. So what do we get here? X square plus b by a into x is equal to minus c by a, right? So now the part is to be observed here. Completing square method means making the LHS part to be as a perfect square. It means either it should be in the form of like a square plus b square plus 2ab, or a square plus b square minus 2ab, like they should be in the form of a plus b whole square, that is equals to what? A square plus 2ab plus b square, or a minus b whole square. It means a square minus 2ab plus b square. So they should be represented in that form, in this form. So here I have a square plus 2 is not here, but I want like 2ab, right? 2ab. So in this case 2ab, 2 is not here. So what I do is taking the second term, that is b by a into x, multiply and divide with the 2. It means x square plus 2 into it means we are multiplying the 2 and divided by 2 into b by a into x is equals to minus c by a. So now again if I write here, it appears like x square plus 2a is x and b by 2a, where 2 into a is equals to minus c by a. Now here it is very closer to a square plus 2ab, right? So let's imagine that this is a square plus 2, a is x and b means b by 2a, right? What we understand here is b equals to b by 2a. It means add b by 2a whole square on both sides. So what happens? It appears like a square plus 2ab plus b square, right? So see here, how does it appear? Now it appears as a square plus 2ab. We want b square, right? So b is nothing that here, with this observation we understood b by 2a whole square equals to minus c by a plus b by 2a whole square. So now this is in the form of like a square plus 2ab plus b square. It means a square plus 2ab plus b square, here it is already written, right? A square plus 2ab plus b square is nothing but a plus b whole square. So similarly this I can write as a plus b whole square equals to minus c by a plus b square by 4a square. Now if you simplify more, what you get is x plus b by 2a whole square is equals to, if you simplify this, what you get is b square minus 4ac by 4a square. Like taking the LCM for the denominators and do that, you will get this. Right, let me do few more steps is left, right? So now what we do is just transferring this square, which is a power 2, towards the RHS. So what happened there? So that is x plus b by 2a equals to plus or minus under root b square minus 4ac by 4a square. This square is for both the numerator and denominator. And if you simplify more, this what happened is x plus b by 2a equals to plus or minus under root b square minus 4ac by, so under root of 4a square is nothing but 2a. Right, now here the final step we get, that is x equals to minus b by 2a. Means I transfer this minus plus b by 2a towards the RHS, and what is more in the left here, like plus or minus under root of b square minus 4ac by 2a. And now we just simplify more here, that is x equals to, as we know both the denominators are the same, right? So that means it is nothing but minus b plus r minus under root b square minus 4ac by 2a. So this is how we solve. This is just a derivation taking the general form of a quadratic equation. So see that in this the few things to be observed. One is The first case, you have to observe that the coefficient of x square should be 1. Okay, so that should be observed. If you have any other number, you have to divide each term with that. If not, it is fine. And then you should be able to convert it in the form of like what? A plus b whole square, like a square plus 2ab plus b square, a square plus 2ab plus b square, to form into this identity. So we should make changes according to the given question.